Okay. So some of these postulates can be proved by logic, by sheer logic, and a property is supposed to be true if it can be proved logically. So by using proper logical statement, properties and all, we can prove a theorem. The logical argument made to prove a theorem is called a proof. So this is a very important thing. What is a proof? So the logical argument or the steps involved in proving the logical argument, that is called a proof. Now, when we are going to prove that a conditional statement is true, now whenever you give a proof for a conditional statement and you're going to prove that it is true, then its antecedent is called as a given part. Antecedent means the statement, the part after if, that is called as the antecedent. So that is called as given, and the consequence is called as the part to be proved. So whenever you see a statement, the antecedent is given part and the consequence is a part which you have to prove by using logical arguments. Now there are two types of proof. So first is a direct proof and second is an indirect proof. Indirect proof you have already studied. Yes, indirect proof we did it in real numbers, first chapter of algebra. Indirect proof is also called as method of contradiction. Okay, and so since you already know what is indirect proof, in this chapter we will be studying what is a direct proof, how we do direct proof. So here an example of direct proof is given. Direct proof of the property of angles made by two intersecting lines. So let's understand this theorem step by step, starting from the statement of the theorem. So the statement of the theorem, this is the opposite angles formed by two intersecting lines are of equal measure. Okay, the opposite angles formed by two intersecting lines are of equal measures. Now, in this statement, although it is not a conditional statement, although this is not a conditional statement, let's see. So in this statement, first we'll see a diagram. So the statement says opposite angles formed by two intersecting lines. So if you see line AB and line DC are intersecting and they're intersecting at point O. And the opposite angles, that is this angle and this angle, they are opposite to each other. These opposite angles are equal in measure. That you have to prove. Is it clear? Okay. So what is given to us? First, always, whenever you write a theorem, always you have to start with what is given. So as we know, this is the antecedent and this is a consequence. Although this is not a conditional statement, it will have an antecedent and a consequence. So antecedent is the given and consequence is what you have to prove. So what is given? These two lines, line AB and line CD, they intersect at point O. Okay, this is given to you. Line AB and line CD intersect at point O. Next, you have to write what to prove. Now, what do you have to prove? The opposite angles are equal. You have to prove that. If the lines are of equal measure, the opposite angles are equal is what you have to prove. Now, which are the opposite angle? First angle is angle AOD. Okay, this angle AOD and angle COB. They are opposite to each other. Also, if you see angle, this one, AOC and this one, angle DOB, they are also opposite. So you have to prove that these two angles are opposite to each other. So theorem, given, and what to prove. Have you understood this?
Yes, sir.
Okay. Now let's start with the proof. Now we have to start with the actual proof. Now, if you see angle AOC, do you remember what are angles in linear pair? Angles that are formed on a straight line, that is like this and this. These two angles will be called angle in linear pair. They measure 180 degree. Now, if you look carefully at just this portion, angle AOC and angle COB, okay, they form angle in linear pair. So angle AOC plus angle BOC will be 180 degree. And for that, the reason is angles in linear pair. Have you understood this first step? Okay. Can you see another angle in linear pair here? Which are there?
AOD and BOD.
Correct. The second one is angle BOD and BOC. Okay, what you said is also correct. AOD and DOB. That also is the same thing. Okay. So BOC and BOD. That is also angle in linear pair. Now, next, if you see, this is taken as equation 1 and this is taken as equation 2. Now, if you see on the right hand side, this is 180 degree of equation 1. On the right hand side, this is 180 degree of equation 2. So in both the equations, the right hand sides are equal. So you just equate the left hand sides. So if these two are equal to each other, these two also should be equal. So that's why we have angle AOC plus angle BOC equal to angle BOC plus angle BOD. Did you understand this step here?
Yes, sir.
Okay. Now if you see one thing, from here angle BOC and this angle BOC will get cancelled. So you are left with angle AOC equal to angle BOD. And that is the first proof. Correct? And then for the second, we can just write similarly. We can prove angle BOC equal to angle AOD. Similarly. Okay, because first you took this linear pair and you took this linear pair here. Okay, so when you want to prove the second part, you will have to take this linear pair like this and this linear pair like this. to prove the second one. But that we can do directly like this. We can say similarly. Have you understood this? Okay.
Yes, sir.
Let's go for the exercise. Okay, so in this, we'll do this orally. We have to just write this in the form of if-then. Okay, we have to just write it in the form of if-then. The first one is the opposite angles of a parallelogram are congruent. How will you write this in the form of if-then?
If the parallelograms are congruent,
It says opposite angles of a parallelogram are congruent.
On third. See on that, I don't know, which edition?
Think about it.
if the opposite angles are congruent, then the parallelogram is congruent.
First of all, what is a parallelogram? A parallelogram is a
Four-sided figure.
what is a four-sided figure called? There's a word for that.
Square.
No, square is just one thing.
Quadrilateral.
Quadrilateral, correct. So we'll say it like this. If a quadrilateral is a parallelogram, okay, if a quadrilateral is a parallelogram, then opposite
Then the opposite angles are
congruent. So this is if a quadrilateral is a parallelogram, then the opposite angles are congruent. Write down the answer. Before you forget, write it down. If a quadrilateral is a parallelogram, if a quadrilateral is a parallelogram, then the opposite angles are congruent. Want me to repeat? If a quadrilateral is a parallelogram, if a quadrilateral is a parallelogram, then the opposite angles are congruent. If a quadrilateral is a parallelogram, then the opposite angles are congruent. In the exact same way, can you think of the second one? Diagonals of a rectangle are congruent. Same, use the word quadrilateral. If a
quadrilateral is a rectangle, then the diagonals are congruent.
correct.
This is remove the clothes now. What is it? Right now. Not this. Outside. Other one.
Done, sir. Done, sir.
Okay. How about the third one? If an isosceles in an isosceles triangle, the segment joining the vertex and the midpoint of the base is perpendicular to the base. How will you do this? Yes, try. If
If and if a triangle is an isosceles triangle, then the segment joining the vertex and the midpoint of the base is perpendicular to the base.
correct, absolutely correct, right?
Done, sir.
Okay, next. In the next one, we have to write a converse. Now, I hope you remember converse. In converse, you just interchange antecedent and the consequence. It's like changing subject to predicate. The first one is the alternate angles formed by two parallel lines and their transversals are congruent. Now, first what you do is first write this in if then in conditions, and then you take the converse of it. So how will you first write it in the conditional form, if then form?
If an alternate angle is formed by two parallel lines. No.
If two lines are parallel, then I'm telling the if then form. After that, we still have to take the converse of it. So if two lines are parallel, then the alternate angles formed by their transversal are congruent. That is the if then form. Now, when you take the converse, if the alternate angles formed by their transversals are congruent, then the two lines are parallel. Do you understand? Okay, first write down the if then form. Write it first. If two lines are parallel, if two lines are parallel, then the alternate angles formed by their transversal are congruent. Now write a converse. Can you try once by yourself now, the converse? Change the antecedent and the consequence. Try and tell me first and then write it down. Can you just read what you wrote? What I dictated
If two lines are parallel, then the alternate angle formed by their transversal are congruent.
Okay, now interchange it and make converse of it. If the
alternate angle formed by
transversal
by
their transversal.
By the transversal are congruent, then the two lines are parallel.
Yes, then the lines are parallel. Or you can, what you said also is correct, or you can say it like this also. If the alternate angles made by the transversal with the two lines are congruent, then the lines are parallel. If the alternate angles made by the transversal with the two lines are congruent. If the alternate angle made by the transversal with the two lines are congruent, then the lines are parallel.
Jerry will finish his class in some time, so you go through the Kachla, so I'll send you.
Okay. Now, second one, if you see it is already in the if-then form, you just have to take the converse. Can you try?
If the lines are parallel, then the pair of interior angles made by a transversal of two lines are supplementary.
Correct.
Yes.
Correct. Right.
1000 rupees में से 100 rupees भी कटा.
Done, sir.
Okay, the last one. Now, first, this last one, you have to write it in if-then form. Now, for it to write it in if-then form, first you use the same way how you did the second one here.
If the quadrilateral is a rectangle, then the diagonals are congruent.
And now you take the converse of that. If the diagonals of a quadrilateral are congruent, then it is a rectangle. Okay, the if-then form will be, if the quadrilateral is a rectangle, then the diagonals are congruent. If the quadrilateral is a rectangle, then the diagonals are congruent. And then when you take the converse, if the diagonals of a quadrilateral are congruent, then it is a rectangle.
Done, sir.
Done? Okay, we'll stop here. I want you to do problem set 1, question 1, 2, and 3 for homework. Problem set 1, question 1, 2, and 3. I think you can do entire problem set. Up to question 8. Up to question 8, you try to complete, and if you have any doubts in question 8, we'll discuss in the next class. Okay, so we'll stop here. Right, see you on Tuesday. Bye.